Hi everybody, I'm Professor Rad, and today we're going to talk about the standard deviation. So this is the second measure of center that we'll be discussing. So to define it, I'm going to say that the standard deviation of a data set is an indication of the average distance each value is from the mean. So if you want kind of a bigger explanation of that, in the previous video, I did kind of a little example and talked about the origin stories here of our standard deviation, where this formula comes from. So you can check out that video if you want. But basically, if you try and find a mean distance from the mean, like how far your numbers are on average from the average, you'll always end up getting 0. Because the things that are below average and the things that are above average end up canceling each other out. So to account for that, we're going to find how far the values are from the mean, square that, find the mean of those, and then square root as kind of a way of compensating for that squaring. So here's how that's indicated in these formulas. Now the formulas look horrific, but bear with me here. So what we do is we're going to take a data value and subtract the average, the mean. So you take data minus the mean, and then you square it. We're going to add that up. That's what that sigma means for all of those data values. We divide by however many there are, and then we square root at the end. So that's our formula for the population standard deviation. For the sample standard deviation, it's almost the same thing, but just to make our lives interesting, different. So in this case, we have our data value minus the mean. It's a different symbol because remember, mu is the symbol for population mean. X bar is the population for sample mean. So we take our data value minus the mean, square it, add all of those up. And then instead of dividing by however many there are, we divide by 1 less than however many there are. And then we square root. So this 1 less than is because when you're looking at a sample, samples tend to have a little bit more variation in them than a population. So this -1 accounts for that. So these formulas, especially with that sigma notation, tend to be kind of confusing to think about. So instead, we're going to use these formulas by completing a table, and then it'll be a little bit easier. So our table, in the first column, we're going to list all of the data values in the data set. Then we're going to subtract the mean, and we're going to call those the deviations. So this is what I did in the last video when I had all of my data, and then I just took away the mean. Then I'm going to take each of those values and square it to get a positive number. Once I get all of those, I'm going to add them all up to get a total value. That's what I'm referring to here in these formulas when I say table total. So I'm going to take that last column, add them all up, and that total I get is my table total. Then I have either my n-1 or my n, and my square root symbol. Now, you do want to be familiar with both your squaring and your square root key on your calculators. So they sound similar, squaring versus square root. So squaring, I'm going to put a little note here, squaring versus square root. Squaring is when you have that little 2. Square root is this little check mark thing. And every calculator is going to have a slightly different way of finding these. Usually, your squaring is going to be an x squared button. So that's what you'll put in. You'll put in your number and then x squared. For the square root, usually you either have a square root button, or you'll have to press second or shift and then your x squared button. So I'm going to look at a few calculators before we go into an example, just to show you where these buttons are. So I'm going to start out here with the TI-30 X2S. On this calculator, my squaring button is right next to the 7. So if I want to do 5 squared, I would do 5x squared. And if my light wasn't in the way, you could see that it puts in 5 squared. That should give me 25. If I want to do the square root, notice that above the x squared on the calculator like base, it has this symbol with the square root. This one is different. So this one above looks similar, but it has a little x there. Okay, so I want the one that's attached to the x squared button. I'm going to press second x squared, and it'll put in my square root symbol. And if I type in 36, it's going to give me 6. So that's how this calculator works. It's got a squaring button, and to square root, I have to hit second squaring button. Same company, a TI, Texas Instruments, but this is the TI-34 Multiview. And on the TI-34 Multiview, we have both an x squared and a square root button. So if I wanted to do 5 squared, I would just type in 5 squared. It'll give me 25. And if I want to square root it, I can do the square root button, 36, and it'll tell me 6. So that's the difference here. We've got our own buttons. I don't have to worry about that second key. So most of the calculators that you're going to see are like that. If you're using some other calculators, you might have to type the number before the square root symbol, but I don't have any of those calculators with me right now. Most of the ones, I've got like 5 or 6 with me, and most of these have one of these two types of options. Either it's an x squared with a second x squared, or a square root and an x squared as separate keys. So grab your calculator and let's go ahead and work through an example of finding a population standard deviation. Okay, so our data set that we have is 5 numbers, and we found the range of this data set in a previous video. So I want to make sure before I go to find the standard deviation that I have the other pieces I need. So I'm going to need the sample size n, or population size. For both, we're going to refer to that as sample size, whether it's a sample or population, and the mean. And this time we're going to find a standard deviation for a mean, and then we'll do another example where we find the standard deviation of a sample, just so you can see how they're similar but different. So I have 1, 2, 3, 4, 5. So my sample size is 5 temperatures. And for the mean, I'm going to add them up and divide by however many there are. Okay, so I'm going to do 22 and 38, 63, 90, 102. That gives me 315. Just going to doodle my work up here. And when I divide that by 5 on screen, I get 63. So my mean is 63 degrees Fahrenheit. Okay, so that's old hat, that's stuff we've done before. Now here's the new thing. So first, I'm going to create my first column. And to do that, I'm just going to list the values in the data set. It does not matter what order I put them in, and I'm not going to label inside the table. Since the table is mostly here just for our work, I'm just going to make sure I label my answer in the end. So I've just taken my numbers here, and I've put all the answers down here. Next, I'm going to move across, and I'll explain why when I'm done. So I'm going to do 22 minus my mean, press equals, and then I'm going to press my squaring button and get this answer here. So our mean is 63. Actually, you know what? To help me remember, I'm going to X out mu and put 63 there, so I know that's what I'm subtracting. So I'm going to do 22 minus 63. That gives me a negative 41. Then, with that still in my calculator, I'm not going to clear it or anything. I'm just going to press my x squared button. And see how on this calculator it says ANS? That means it's taking my previous answer and squaring it for me. That's what we want to have happen. I get 1681. That's going to go over here. So if I want to give myself a note of what I did, here I did 22 minus 63 equals. Then I hit my x squared button equals and got 1681. So we're going to do that for each value in this column. So I'm going to do 38 minus 63. That gave me a negative 25. Then I'm going to hit the x squared equals. Oh, I realized my keys aren't all on screen. So I hit the x squared and then equals, and that gave me 625. Next, I'm going to do 63 minus 63. Gives me 0. That makes sense. X squared should also be 0. Good. It's good to test your calculator now and again. Then I'll do 90 minus 63. I get 27. Then I'll press x squared, and I get 729. And lastly, 102 minus 63. That gives me 39. Press the x squared and hit enter, and I get 1521. All right, so that's the process for filling in these two columns. Now, the reason that I do this process instead of just always subtracting and always squaring is there tend to be a couple of common mistakes that are done. Notice that I didn't even really use this column heading as any kind of heading. The only thing that's important is the squaring piece. So the square says I'm going to square the previous column. What I tend to see happen as a common mistake when we fill in just the first column and then the next one is I tend to see people putting in negative 41 minus 63 and then squared, and that's wrong. This x is referring to 22. The x is not referring to this number we got here. So I find that if I do that subtraction and then do x squared right away, I tend not to make that mistake. The other thing has to do with how your calculator interprets order of operations. So let's see how this one interprets it. If I filled in just this column, if I typed in negative 41 and then hit x squared, notice that it gives me a negative 1681. But before, we had a positive 1681. So if I'm following my order of operations, what this says to the calculator is the calculator interprets this as square 41 and then make your answer negative. That's not what we want. We want it to square the whole negative 41. So notice if I put parentheses there, I end up with a positive. So when I use the method that I used here, and my calculator says ANS, it's already putting in these parentheses, so I don't have to worry about that. So that's why I recommend this method of doing the subtraction and then pressing the x squared button. So you want to make sure you practice that so you get into the habit of it. But a note I might make is that this column is always positive or 0, but it's always positive. It can't be negative. Okay, so we did get a 0 here, but all of these numbers were positives. So once I have that done, I can go ahead and add up all the numbers in this column. So that's what I'm going to do. I'm going to do 1681 plus 625 plus 0 plus 729 plus 1521. And that gives me 4556. And then what I like to do, this is just a me quirk, I like to add back up just to make sure I didn't mistype anything as a check. And I get the same answer, so it worked out. Whew, okay. So far what we've done, this, if I go back to my standard deviation formula, that table total we found is this portion of the formula. So we just found sigma x minus mu squared. That's what that table total represents. So to finish with this formula, we're going to take that number, divide by however many things there were, and then square root the answer. Or in the simplified format, I'm going to take the table total, divide by however many things there were, and then square root it. So I'm going to take this table total, 4556, divide that by however many things there were. So there were 5 temperatures. And then square root the whole thing. Make sure you make that square root sign nice and big, because otherwise you'll only be square rooting the top instead of including the bottom in there. So if I follow my order of operations, I do division first. So I'm going to do 4556 divided by 5, and that gives me 911.2. So this is the square root of 911.2. And then on this calculator, to get to my square root, it's on the calculator base here. So I'm going to press second x squared. And then I'm going to do 911.2. Enter. And I get this nice, lovely decimal. So what did we get? I'm going to put approximately equals to here because I'm going to round this eventually. So we've got 30.1860891. And if I go back up to the top in my directions, it said to the nearest thousandth. So I find where my decimal point is. So right here. That means this is the 10th, 100th, thousandths place. So the digit just to the right is less than 5. So that means that 6 stays. So I'm going to get 30.186. And my units are the same as the units for the temperatures. So 30.186 degrees Fahrenheit. Whew. Okay, so now if you're wondering, do you need to do this in 2 steps? The answer is no. So I'm going to type off on the side here how I could find this in one go on my calculator. So I'm going to press on this calculator the keys that I need, and I'm going to do the sequence for getting a square root first. So if your calculator has just a square root button, you would just type in just square root. On this one, I'm going to do second and then x squared. So let's see, I'm going to do second and then x squared. And in this case, do you see how this box is underneath this radical sign? That means I don't have to put in any parentheses. I'm going to show you on another calculator. On this one, when I press second x squared, notice that it puts a parentheses there for me. So I want to make sure that my calculator is doing that. So let me see if I have one. Yeah, I don't have one that doesn't do that for me. So I think we should be okay. But if your calculator has just a square root sign with no parentheses and it doesn't have this box inside, you want to make sure you have a parentheses there. Then I'm going to type in this 4556 divided by 5. And then if you have a parentheses there, you want to close the parentheses up and then press equals. So I'm going to put the parentheses here just in case I needed them, just so I know where they go. So, and if I put them here, it's not going to hurt it. So 4556 divided by 5, close it up, hit enter, and you can see I get the same answer. And if I try my green calculator, I'm going to do second x squared. It puts that parentheses in there for me. 4556 divided by 5, close it up, hit equals, and I get that same decimal that we got before. So you want to make sure that you understand your calculator and how it interprets the inputs, because they're all going to be just slightly different, just to make our lives, that much easier here. All right. So now let's do another example, because one of these isn't enough, right? Let's get some more practice in here. So everything is going to be the same up until the end of the table. So this problem is going to be pretty similar to the last one we did until basically the last step or two. The other thing I want to point out is in this case, they gave us, what are these? These are the earnings in billions of dollars for the 6 most profitable companies worldwide in 2024. So this is how much money they earned in billions of dollars. And then they tell us that the mean is $140 billion. So there are two things happening. First, they're telling me the mean. And secondly, they're treating $1 billion like a label. So I can see that here as well. I've got 236. That means $236 billion. So I'm going to leave the billions off of the numbers when I go to input them into the table. So I'm just going to put, for example, 236. And the next one is 157. And so on. And then when I subtract the mean, I'm going to subtract just 140. So I'm going to treat $1 billion kind of like a label in this case. So what I would like you to do is I'd like you to pause the video here and see if you can fill out this table. So practice using your calculator to fill out the table. And then once you've got the table done, you can go ahead and unpause and we'll finish finding the standard deviation together. Okay, so hopefully you took some time to practice creating this table on your own. Let's compare and see how we did. So I put all of my X values here. So put all my earnings. And then for this next column, I did, for example, 236 minus 140. That gave me 96. Then I hit the X squared button and it gave me 9,216. So going down this last column, I got 289, 225, 361, 1225, and 1936. And when I added all of those up, I got 13,252. Remember that every number in this right-hand column should end up being a positive number. So if you got negatives, that means you probably put it into the calculator in the wrong way. And then another thing, kind of as a reminder, remember we have to do this whole squaring and square root business because these numbers should always add up to be 0. So if you want to do a check, another check, we can add all of these up. And if we get 0, then we're in good shape. Haha, excellent. Now, sometimes you might get a number that's a little bit off from 0 because of rounding the mean. But in this case, that didn't happen. Okay, so here is where sample standard deviation is different from population standard deviation. So this is a sample of corporations. It's the 6 most profitable, but it's still a sample. So we're finding a sample standard deviation. So in this case, I'm going to take that 13,252, and instead of dividing by n, I'm going to divide by n minus 1. So remember, n is the number of numbers that you had in your data set. So it should be 1, 2, 3, 4, 5, 6. So I'm going to divide by 6 minus 1 and then square root it. Now, just like I did for population standard deviation, I'm going to go ahead and go through this on my calculator following the order of operations, and then I'll show you how you can type it in one go. So first I'm going to do 6 minus 1 to get 5. So I've got 13,252 over 5 square rooted. So I'm going to do 13,252 divided by 5. That gives me 2,650 and 4/10, which I'm then going to square root. And then my square root button on this calculator is also second x squared. Now I'll point out, if you get a gnarly decimal here, most calculators are going to have an answer button. So instead of typing that in, I can hit second negative sign, and it's going to square root that answer for me. So if I hit enter now, I get 51.4820357. Running off screen here. Okay, so we want our standard deviation to the nearest 1/10 of $1 billion. So here's my decimal point. So the first spot is tenths. Since the 8 is 5 or more, that 4 goes up to a 5. So I'm going to get $51.5 billion. Make sure that I label this at billion, because if a company only made $51.50, that would be not very profitable. And then that $sign to indicate dollars. Now, the way that I'm going to type this into my calculator all in one go is I'm going to start out by doing that square root. And then I'm going to do 13,252 divided by, just like I would before. Now, in order to tell the calculator to do the subtraction before the division, I need to put parentheses in, 6 minus 1, close up those parentheses, and then hit enter. And you can see this calculator is giving me the same thing that I had here. The way that looks on the green calculator, which has a few more parentheses involved, is like this. So I'm going to do my square root, and it puts that parentheses in there for me. 13,252 divided by another parentheses, 6 minus 1. I close the parentheses for the bottom, and I close the parentheses for the square root. Then I hit enter, and it gives me the same answer. So depending on your calculator, you may need a different number of parentheses. All right, so that's going to wrap up this video on standard deviation. In the next video, we're going to find a third measure of dispersion called the variance. And the variance is not hard to find if you found the standard deviation first, because the variance is going to be based off the standard deviation. So I'm looking forward to seeing you then. In the meantime, have an excellent day.